Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 5.3, day 1, entitled Trigonometric Graphs. And today we're going to talk about how you graph sine and cosine functions. And we'll talk about a few of the transformations that we'll be able to do, but not all of them. Now, when we're graphing sine and cosine functions, you have to remember that their graphs look kind of like a wave. So they go up, and then they go down, and then they go up, and then they go down. So they're cyclical, or as we refer to it in mathematics, they're periodic. So all of the functions that we're going to graph for sine and cosine, they're going to be periodic. And their period is going to be 2 pi. So every 2 pi, they're going to repeat. So a little bit better way to write the functions looks this way. Okay, here we have the sine of t. Your book uses t instead of x. Okay, so if we're graphing the sine of x, that really means it's going to be the sine of x plus 2 pi, because after every 2 pi on your graph, the cycle will repeat. And the same thing for cosine. Cosine of x or cosine of t is really the cosine of t plus 2 pi, or x plus 2 pi. Okay, so it's good to remember that the sine and cosine functions, they have a period of 2 pi. Now, we have this table here. It's also in your book. And the table of values that's listed here has almost every increment around the unit circle. It doesn't have the 45-degree angles. I don't know why those are not included in the chart, because they could be here too. And the sine and cosine values for those would be the square root 2 over 2. But the main values that we're going to focus on when we're graphing are going to be 0, and then pi over 2, and pi, and 3 pi over 2, and then 2 pi. So we're always going to start at 0, and we're going to go to 2 pi, because that's the cycle. That's the length of the period for a sine and a cosine graph. And then we're going to do the pi over 2 and the pi and the 3 pi over 2, because those are every 90 degrees, basically. And you'll notice that these values then have very nice whole number values. They're zeros and ones. Okay? So that's why we like to use those. So we get a very easy table of values to construct. Now, when we graph these, we're going to be graphing on a special trigonometric graph. I have graph paper in the classroom. I have graph paper on the class website. Or you could search for some, if you would like, on Google and find some trigonometric graph paper. Sometimes it's easier just to make your own graph, but when we're starting with these simple graphs, it can be nice to have the graph paper. And notice that on the x-axis, they have marked pi over 2, pi, 3 pi over 2, and 2 pi. And then on the y-axis, it's every 1 increment. Okay? So if I was going to graph the sine of t, okay, sine is going to start at 0, 0. It always starts at the origin. And then at pi over 2, it's going to go up to 1. And then at pi, it comes back down to 0. And then at 3 pi over 2, it goes to -1. And then at pi over 2, it comes back up to 0. So you really just have to remember those values. Okay, 0, 1, 0, -1, 0. And that is what your basic sine function looks like. So if you graphed sine of x in your graphing calculator, it should look something like that. And then if we graph the cosine function, notice that cosine starts up at 1. It's always going to start at 1 on the y-axis instead of at the origin. And then it goes down to 0. Then it goes to -1, comes back up to 0, and then goes back up to 1. So this is what your cosine function will look like. And again, if you graph that in your graphing calculator, that should be what you see. So you have to remember that the sine function starts at the origin, starts at 0, and the cosine function starts at 1. Okay, so there's a little bit more thorough graph of what the sine function looks like. And here you can see that it's going to repeat no matter how many cycles we do, that shape is going to repeat. So here you can see there's 2 periods. They did 1 period of 2 pi and then another period of 2 pi. And notice that it repeats towards the negative x-axis as well, or towards the negative side of the x-axis. So I just drew it for the first few values on the positive side of the x-axis, okay? But you could go back the other way as well. And same thing for cosine. Here's a more thorough graph of what the cosine function looks like. And here again, you can see the same values repeated for 2 cycles there, or 2 periods. So the sine function, when you look at it, it's going to be symmetric around the origin. And then the cosine function is going to be symmetric around the y-axis. So if you folded the graph horizontally, I guess, so that you were folding it on the x-axis, that sine curve, I'm sorry, the cosine curve would line up from the positive side of the x-axis to the negative side of the x-axis. When you fold it over, it would line up perfectly. Okay? All right, now we're going to graph a little bit more complicated cosine functions now. But they're not going to be too super duper complicated yet. But we're just going to see a little bit of a transformation here when we're graphing this one. Okay, so we're going to graph 2 plus the cosine of x. Now there's all different kinds of transformations that we've seen with graphs throughout the whole semester. We can move them up, we can move them down, we can move graphs left or right, we can reflect them around x-axis or the y-axis or the origin. We can make them stretch out or we can make them shrink down. So we're going to see all those types of transformations with the trigonometric functions. Well, we're just going to start off with an easy one here with adding 2. So we're going to have the cosine of x, and then we're going to add 2 to it. So just like any function that we had, if we had just x plus 2 or x squared plus 2, that's going to take our whole graph from its starting point and it's going to shift it up on the y-axis 2 units. So when we make our table of values, I like to make my table of values horizontally for the trig functions just because it saves a little bit of room. And we're going to start at 0, and then we'll do pi over 2, and pi, and 3 pi over 2, and then 2 pi. And again, those are the values that we're going to be using very often, okay? The majority of the time. Sometimes they'll change, but those are going to be the values that we're going to use. Now, normally cosine starts at 1, but I'm going to add 2 to it. So that'll get me an f of x value of 3. And then it goes from 1 to 0 to -1, back up to 0, and then back up to 1. So that's traditionally the movements or the graph of a standard cosine function. But again, I'm adding 2 to all these values. So when I have -1 plus 2, now I'm at 1. 0 plus 2 is 2, and 1 plus 2 is 3. Okay, so if you know those x values from your unit circle, and if you know your y values for the very basic cosine function, then you just have to alter the y values by adding 2 to them for this graph. So I'm going to start at 0, 1, 2, 3, and then at pi over 2, I'll be at 2. At pi, I'll be at 1. Through pi over 2, I go back up to 2. At 2 pi, I go back up to 3. So again, we have our cosine curve that goes down, and then back up. Okay, normally the standard cosine function starts at 1, but now everything has been shifted up 2 units. Okay, so let's take a look at this one. Example 1, part B. We're going to graph negative cosine x. So again, I'm going to make my table of values. I'm going to use 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. And normally the cosine function starts at 1 and then it goes to 0 and then negative 1 and then back up to 0 and back up to 1. But for this function, I have to multiply all of my y values by a negative 1. So I'm going to have 1 times negative 1, that'll get me a negative 1. 0 times negative 1, that still gets me a 0. Negative 1 times a negative 1, that'll get me a positive 1. 0 times negative 1 is still 0, and 1 times negative 1 gets me a negative 1. So now I can see that my graph is basically going to be flipped upside down. I'm going to start at negative 1, then I'm going to go to 0, and then 1, and then back down to 0, and back down to negative 1. So my graph has been reflected or flipped around the x-axis. Okay, so there's the book graph of the example A that we did. There's a book graph for example B. Okay, so hopefully knowing those rules for transformations still applies very easily to what we're doing now with the sine and cosine graphs. And for this example here, we're not really going to graph all of these, but we're just going to talk about what you would do. What do these transformations do to the function y equals sine of x so that you get these graphs? So how would you transform them? Now notice in part A, we have y equals 2 times the sine of x. So since I'm multiplying by 2, that means I would have to multiply all my y values by 2 in my table of values. So I would still use 0 and pi over 2 and pi and 3 pi over 2 and 2 pi for my x values. But then the standard y values of 1, I'm sorry, 0 and then 1 and then 0, negative 1 and 0, that is what I would multiply by negative 2. I'm sorry, by 2. Okay, so for part B, I have a 1/2 or a 0.5 sine of x. So you could think of this a couple different ways. You could multiply your y values by 1/2 or 0.5, or you could divide by 2. It's the same thing. And then negative sine x, that's just like the negative cosine x that we saw. So there you would want to multiply all your y values by negative 1. Okay, so again, you would make your table of values, you'd pick your x, you'd have your f of x, we'd start at 0, and then pi over 2, and then we'd have pi, and then 3 pi over 2, and then 2 pi. Okay, and normally the sine function starts at 0, and then it goes to 1, it goes back to 0, and then negative 1, and then 0. So these values in the f of x column or row, that is what you would multiply by 2 or divide by 2 or multiply by negative 1. Okay, so then here's pictures that go along with those graphs. Okay, so when you multiply it by 2, it's going to make it 2 units tall. When you multiply by a half, it's going to smush it, so you're only going up halfway. Instead of going all the way up to 1, you go up to a half. And then for the negative sign of x, it's going to flip it upside down. Okay. So there's one other concept that we're going to talk about before before we're done for today, and that is the amplitude. That's the other concept that we're going to talk about. And this is a type of a transformation, and this is basically what happens when you have a number in front of the sine of x or the cosine of x. Okay, so we'll just call it A for amplitude. And when we're finding the amplitude, we have to remember that it's the absolute value of A. So even if this A is a negative number, we're still going to be the absolute value of that number is how tall the graph is going to be. Okay, so for example 2, this is going to be our last one for today. We're going to find the amplitude, and then we're going to make the graph for this one. So we have -3 cosine of x. So the amplitude is going to be the number that's in front of the cosine of x. That's our -3, but we want the absolute value of it. So our amplitude is really 3. So that means I'm going to go up 3 units, and then I'm also going to go down 3 units. Okay. And then when I make my table of values, I have x, and then technically I have y this time. Okay, and we're still going to start at 0, and then do pi over 2, and then pi, and then 3 pi over 2, and then 2 pi. Now normally the cosine function starts at 1, and then 0, and then -1, and then 0, and then 1. Now I've got this -3 that's out front, so I'm going to multiply everything by the -3. So then I'll get -3 here. Still get a 0 there. Then I get a +3 here. And then we go back to -3. So that negative flips it around the x-axis, or rotates it around the x-axis. And then the 3 is going to make it 3 units tall instead of 1 unit tall. So I'm going to start at -3. And then I'm going to go up to 0. Then I'm going to go to +3, back to 0, and then back to -3. So this cosine function is a lot taller than the original ones that we graphed. Now when you're graphing these, try and make these little, these points that connect, try and make them curved somewhat so it looks kind of like a wave. Don't make them straight lines. We don't want it to be a V, so try and make it a little curved. Okay. So this is very standard, very straightforward, very basic graphing that we're doing here with the sine and the cosine functions. In the next section, we'll get a little more advanced, but you definitely want to practice these concepts now while they're easy, especially making those table of values and graphing it, because again, that's going to get more complicated too. So practice these problems now so you get the basics down, and then we can build upon that in the next few sections. Remember, I have the solutions worked out in the binder in the classroom, or you can stop on by and see me before school.